All right, good morning, folks. It is Tuesday, and we are ready to begin a new chapter. So, moving on from solving inequalities, in the next chapter, we are going to focus our attention on functions. This is a fairly short chapter, and one of the simpler chapters. So we're going to be talking about functions. Now, in order to talk about functions, we have to start with a little bit of review. And what we need to review is the idea of an ordered pair. Okay, now you have dealt with ordered pairs for many years now. And what you know is that when you have an ordered pair, it will come to you wrapped in a set of parentheses. And inside of those parentheses, there will be two numbers, and those two numbers will be separated by a comma right there in the middle. Now, it's called ordered because the two numbers are always in the same order. What you have learned in the past is that your first number is your x-coordinate, and your second number is your y-coordinate. So anytime we see an ordered pair, there will always be an x paired with a y. X will be first, y will be second. Now, you know that you used ordered pairs in order to graph things. So let me see here if I can remember where my graph paper is on this thing. And here it is. So I'm going to put a grid on the board here. And real quickly, I'm going to put a graph on here. So here is an x-axis. And then here is a y-axis. So this is that coordinate plane that you're accustomed to seeing when you're graphing. Now, what you know is that this point right here, where those two number lines intersect, that point is called the origin. And if I look at the ordered pair for that origin, the x-coordinate would be 0 because I'm at 0 on this x-axis. And then I am also at 0 on this y-axis. So you know that that origin corresponds to 0 on both of those number lines. Now, on your x-axis then, if this is 0, then over here to the right, you would have your positive numbers. And then over here to the left, you would have your negative numbers. And then likewise on our y-axis, if this is 0, up here at the top, we would find our positive y values. And then down here below that 0, you would find your negative y values. So all of those are things that you are familiar with. Now, what you have done in the past is you have learned to graph things like 5, 3, 5, 3. Now in that ordered pair, the x is the 5 and the 3 is the y. All right, so here's what I would do. Starting from the origin, on the x-axis, I want to go to positive 5. So that means I would go to the right 1, 2, 3, 4, 5 spaces, which would put me right here. And then on the y-axis, I want to move in the positive direction 3 spaces, so I would go up 1, 2, 3 spaces. And then right here is where I would put my dot. So that dot right there that I just made corresponds with that point, 5, 3. I go to positive 5 on the x-axis, positive 3 on the y-axis, and that would be my location. All right, let's say that I've got the ordered pair, negative 4, 1. Negative 4, 1. That means that x is negative 4 and y is 1. So again, starting from the origin, on the x-axis, I want to go in the negative direction 4 spaces. So that means I would go to the left 1, 2, 3, 4. And then on the y-axis, I want to go in the positive direction 1 space. So I would move up 1. So right there is the point that would correspond with that ordered pair negative 4, 1. All right, let's try something like negative 3, negative 2. So in that point, my x is negative 3 and my y is negative 2. So again, notice I begin at the origin again. I want to go on the x-axis in the negative direction 3 spaces, so to the left 1, 2, 3. And then on the y-axis, I want to go in the negative direction 2 spaces, so I would move down 2. So right there's where negative 3, negative 2 would live. All right, let's do maybe one more. So let's use this orange color here. Let's say that I want to go 5, 0. 5, 0. So my x is 5 and my y is 0. So starting from the origin, I want to go in the positive direction on the x-axis 5 spaces. So to the right 1, 2, 3, 4, 5. And then notice on the y-axis I want to move 0 spaces. So I would stay right there. Now, let's do one last thing with this before we move on. I mean, this is all review, so this is stuff you already know. Let me pick, I'm out of colors here that will really work. I'm going to use that ugly brown color. So there's my ordered pair for, or there's my point for that. I should also be able to take that point and figure out what its ordered pair would be. Okay, so what I have to keep in mind is this first number needs to tell me the x coordinate, and this second number needs to tell me the y coordinate. So starting here from 0, first I would figure out how I move on the x-axis. Well, I'm going to the right 1, 2, 3 spaces. So I've gone to the right 3 spaces. So I have gone to positive 3 on the x-axis. And then I have gone down 1, 2, 3, 4, 5 spaces on the y-axis. So if I've gone down 5, then I've gone in the negative direction. So that would be negative 5 for my y-coordinate. So 3, negative 5. So we begin our discussion of functions by reviewing ordered pairs. Ordered pairs will always come to you wrapped in a set of parentheses. The x will be the first number, and then a comma, and then the second number will be the y. So notice that in these ordered pairs, an x is connected to a y. An x is connected to a y. All right, so the reason that I'm making that distinction is because when we talk about a function, a function's job in algebra, is to connect x values to y values. So anytime you think about functions, I want you to think about connections, because that is a function's job. A function's job is to connect an x value to a y value. So if I draw this box to represent a function, just to kind of give you a visual, an image of what's going on here, what will happen is a function will take an x that you give it and connect that x to a y value that it determines. So this is how a function works. It takes an x value that you give it and then connects that x to a y value that it determines. Okay? Now, x values have some other names, and as I tell you what these are, I am quite certain you will remember hearing them. Okay? An x value can be referred to as domain. an x value is also referred to as an input. So x values go by a couple of other names, domain and input. Y values go by a couple of other names as well. Range is one of those. So you may remember hearing a lot about domain and range. And then if x is the input, then that means that y will be the output. And we'll be talking about those two terms, input and output, a lot more in tomorrow's lesson, in our next day's lesson. So a function's job is to connect x values to y values. The x, which is the domain or the input, will be connected to a y, which is the range or the output, and the function is what makes that connection. So I want you to notice here how that kind of relates to what we were just talking about. A function connects an x to a y, and so what it does is it creates ordered pairs. The ordered pairs show you who is connected. All right, now, the next thing we need to talk about is this. A function has a really important limitation placed upon it, okay? Which means that a function can't connect just any x with any y. It can't behave just any old way it wants to. There is a limitation on functions that is really, really important for you to know, okay? And here is that limitation. In a function, x values cannot be repeated. So in a function, x values cannot be repeated. X values cannot be repeated. So another way to say that is functions have no repeating x values. So when you hear the word function, I want you to think just that. That's what I want to be in your head. I want you to think no repeating x values. No repeating x values. Now I want you to notice what that says. It says in a function x values cannot be repeated. It doesn't talk about y values. So y values have nothing to do with whether or not something is a function. All we're concerned about is x's. Functions can have no repeating x values. All right, so you are going to be doing some examples where you are given ordered pairs and you have to decide, is this a function? Is it a function or not? So that is the question you're going to be answering on the assignment that you do today. Is it a function? All right, now here's what I want you to remember. This is that point when they ask you, is it a function? This is that point where I want you to think about that word function, and I want you to think no repeating x values. All right, so when I come down here and I look at these set of ordered pairs, I want you to remember what I said about a function, that it connects an x to a y. So in this ordered pair, x is -2 and y is 6, so -2 and 6 are connected. 2 is connected to 0, 3 is connected to 6, 4 is connected to -1, 5 is connected to 3. So these are the numbers, the x's and the y's that are connected. I don't care about these y values at all, because in a function I want no repeating x values. So x values are what I need to focus all of my attention on. So I'm going to go through this set of ordered pairs and I'm going to look. I have -2 for x, I have positive 2 for x. I have 3 for x. I have 4 for x. I have 5 for x. So were any of those repeated? No. I saw negative 2 one time, and then I didn't see him again. I saw 2 one time, 3 one time, 4 one time, 5 one time. There are no repeated x values up here. They're all different. So when they ask me, is it a function, I would say yes. This is a function. It connects x's with y's, and it meets the conditions of that limitation. It doesn't have any repeated x values. A function cannot have x's that are the same, and this doesn't. So yes, this is a function. Pretty easy, especially compared to some of the stuff we've been doing. All right, here's another set of ordered pairs. Is this a function? All right, first of all, I don't care about the y values. I don't want to look at those at all. They don't matter to me. What matters are the x's, which are the first numbers. So I have negative 3 for an x. I have negative 2 for an x. I have positive 1 for an x. I have negative 3 for an x, and I have 0 for an x. So let's look at those x's. Are any of them the same? Did any of those x's repeat? Well, yeah, they did this time. This ordered pair had negative 3 for x. This ordered pair also had negative 3 for x. The others were different. I had negative 2 and 1 and 0. But the fact that I have these two x's that are the same, the fact that this negative 3 has repeated means that no, this is not a function. So this is not a function, and it's not a function because it repeats that x value of negative 3. Two of the x's are the same. So what I'm looking for when I look at a set of ordered pairs, and I want to know, is it a function or is it not? What I'm looking at is the x values, and I want them all to be different. I want them all to be different. If any of them are the same, if any of them are repeated, then it is not a function. So listen to that. If it repeats, if it does repeat, then it is not a function. If it doesn't repeat, then it is a function. All right, so let's look at another one. Now notice this time your ordered pairs are presented in a different way. We have this presented in a function table. So your x is on the left, your y is on the right. So this would be an ordered pair. Negative 2 connects with negative 3. This would be an ordered pair. Negative 1 connects with 0. This would be an ordered pair. 5 connects with 5. This would be an ordered pair. 4 connects with 3. And this would be an ordered pair. Negative 1 connects with 7. It's just written in a different way. Now again here, if I want to know if this set of ordered pairs is a function, I would ignore all of these y values over here. They don't matter to me. What matters is what's going on with the x's. I have negative 2. I have negative 1. I have 5. I have 4. And I have negative 1. Are any of those the same? Are any of those repeated? And the answer is yes. I do have a repeated number. Negative 1 was my x value up here. And then negative 1 was my x value down here as well. So I repeated that x. So because I repeated that x, I'm going to say no, this is not a function. A function cannot repeat x values. So anything that does repeat an x value cannot be a function. It's as simple as that. All right, now here is yet another way to present ordered pairs. Notice that in this first bubble you have your x's, and in the second bubble you have your y's. And remember what I said. They're supposed to be connections. Well, how are those connections being shown? Those connections are being shown by these arrows that are drawn from the x's to the y's. So real quickly here, let's take a moment before we decide if this is a function to change this from the form that it's now in over to a table. All right? Your first x value is a 6. So I'm going to put a 6 here in that x column. And then I'm going to look for what he connects to. Well, the first thing I see is that 6 connects with 3. So if an x value is 6, then a y value would be 3. But I notice that's not all. I also notice that there's another arrow showing me that 6 connects with 5. So I would put a 5 over here in that y column, and the x there would have to be a 6. So 6, 3 would be one connection, and 6, 5 would be another. Then I have a 7 for my x value. Well, that 7 only connects with -4 over in that y column. And then I have an 8 for my x value, and that 8 connects up with 1. So here is this same information being presented over here as a table. All right, now let's decide, is it a function? Well, first of all, if we want to know if it's a function, we're not going to look over here at all. We don't care about y when we're talking about a function. What we care about is x. So my x's are 6, 6, 7, and 8. Remember what I'm looking for. Did I repeat any of my x's? I surely did. I have 2 6's. So because I have repeated an x, I'm going to say no. This can't be a function. This is not a function. So in order to be a function, all of the x's have to be different. Every single x has to be a different number. If 2 or more of them are the same, then it cannot be a function. All right. So the function's job is to make connections between x's and y's. X is called domain or input, y is called range or output, and the limitation on a function is that x values cannot repeat. In a function, every x value has to be different. None of them can be the same. All right, so the second thing we're going to look at is something called the vertical line test. You all know what a line is. I want to remind you here that a vertical line is a type of line that goes up and down. Up and down. So when I talk about a vertical line, whoops. When I talk about a vertical line, right there's the kind of line that I'm referring to. Now, this is something that, again, you would have done in the past, all right? Vertical line test is used on a graph. It's used on a graph, and it will tell you if a graph is a function. Now, here's what you need to know. In the vertical line test, each vertical line that you draw on the graph can only intersect or touch one point on the graph. So that's how it works. Each vertical line that you draw on the graph can only intersect or touch one point on the graph. So let me show you what I mean by that. Okay, x-axis, y-axis. Let's say, I'm going to use blue. Let's say I have a graph that looks like this. So when I refer to the graph, I'm referring to this blue V shape. So that is my graph, is that blue V shape, okay? What I'm going to do, I'm going to use red, and what I'm going to do is I'm going to draw, well, that's not very straight. I'm going to draw a vertical line up and down across that graph. Now here's what you want to look at. Where does the red line touch the blue line? So where does that red line touch that blue line? Well, the answer is right there. Right there. And what I want you to notice is that that red line only touches that blue line at one spot, at one point. So this is what this statement down here at the bottom of the screen means. That vertical line that I've drawn on the graph only touches the blue graph at one point. Okay? If I move over a little bit and I draw another red line, I would look at how many times that red line touches the blue line. Well, I see it touch right there. But that's the only place it touches the blue line. So again, notice that touches the graph at one point. If I move over a little more and I draw another vertical line, I'm looking for where that red line touches the blue line. It touches right there. And that's the only place, so that's one point. Let's do one more. Vertical line right here. Where does this red line come into contact with the blue line? At that spot right there. So what I want you to notice is I've drawn 4 vertical lines. 1, 2, 3, 4. The first one I drew touched one point on the blue line. The second one I drew touched one point on the blue line. The third I drew touched one point. The fourth I drew touched one point. So each vertical line that I drew touches the graph at one point. So this is a function. That is a function. All right, so let me show you what it would look like if it wasn't a function. So let's see if I got enough room here to do this. All right, here's another x-axis. Here is another y-axis. This time, let's make our graph turn like this. So I'm going to use that same blue V-shaped graph, but I'm going to turn it on its side. So when we talk about the graph, this blue sideways V is what we're talking about. All right, so I'm going to get my red marker again, and I'm going to draw a vertical line right here, up and down on that graph. And what I want to do is look and see how many times that red line that I just drew comes in contact with my blue graph, with that shape. Well, I can see the red line crosses the blue line right there, so they touch right there. So that's one point. And then I can see that this same red line also touches the blue line right here. So there is one vertical line touching the blue graph in 2 points. That's what I don't want. So this is not a function. Not a function, because one vertical line is touching 2 points. Each vertical line is only allowed to touch 1 point. If one vertical line touches more than 1 point on your graph, then that is not a function. All right, so I've got some graphs here we can look at now, and you'll notice I've already made us a vertical line that we can use here. So this graph is made up of 1, 2, 3, 4, 5 dots. All right. You'll notice also that your grid has vertical lines already on it. You can use those when you're looking at these for the vertical line test. But just to emphasize it, I'm going to go ahead and use this guy. All right, so I'm going to slide my red vertical line all the way over here to this first point. I want you to notice when I place my vertical line on this graph, that vertical line only touches one of the dots. It touches this one. And you know, if you go back to how we started today, you could figure out that ordered pair. All right, on the x-axis, we're going in the negative direction, 1, 2, 3, 4 spaces. So that would make this x-coordinate a -4. And on the y-axis, we're going in the positive direction, 1, 2 spaces. So that would be -4, +2. All right, let's grab our vertical line and let's drag him over a little bit till he's on that next point. You'll notice again, this vertical line is only touching one dot. And the dot that he touches is this one. And again, I could write an ordered pair for that. So on the x-axis, starting from the origin, on the x-axis, I'm going in the negative direction 1, 2 spaces, so -2. And then on the y-axis, I didn't move. So my y would be 0 for that point. So that point is -2, 0. But notice the vertical line is only touching one of the dots. All right, so if I move over a little more, notice when I put the vertical line in this position, how many of the dots on that graph am I touching? Well, I'm only touching one of them, and that's this one. So if I do an ordered pair for that, starting from the origin on the x-axis, I don't move. So that would be 0. But on the y-axis, I go in the negative direction 2 spaces, so that point would be 0, -2. But notice again, vertical line only touching one of the dots. All right, move over to here. How many of the dots is that vertical line touching? Well, that vertical line is only touching one dot right there. Ordered pair for that. On the x-axis, we go in the positive direction 2 spaces. On the y-axis, we don't move, so 2, 0. All right, and we got one more to go. Move the vertical line over one more time. Notice it is touching one dot and one dot only. That dot is this one. On the x-axis, we're going in the positive direction 1, 2, 3, 4. On the y-axis, positive direction 2 spaces, so that point would be 4, 2. Now, I'm going to grab my vertical line and move it off of the grid now so we can look at this a little more closely. I want you to notice that each time I moved my vertical line, I only touched one of the dots at a time. That's a good sign. That means I have passed the vertical line test. And then to also drive home that this would be a function, look at these x values, because we know that x values determine if we're functions or not. We have -4, -2, 0, 2, and 4. None of those are repeated. None of those are repeated. So each vertical line only touched one dot on the graph. None of the x's are the same. So yes, this is a function. Each vertical line only touched one dot on that graph. All right, now take a look at this graph. What you'll notice right off the bat is that you don't see any dots. That doesn't mean anything bad though. This vertical line test is still going to work the same way. So I'm going to grab my vertical line and I'm going to drag him over here to the graph, and I think I'll place him right here. Now my graph this time, let me stress this, my graph this time is this U shape that's turned on its side. So when I talk about the graph, I'm talking about what I just highlighted in yellow. And so what I would want to do here is I would want to look at where this red line touches this yellow graph, this shape that I have graphed here. And what I see is the red line touches the graph right there. So there's one dot where it touches. And then the red line touches the yellow graph also down here. So two different places. Remember what we're allowed. Each vertical line is only allowed to touch one point. This vertical line has touched two. So this would fail the vertical line test. So no, this is not a function. You want each vertical line to only come in contact with the graph one time. Now let me show you why this would not be a function. If we were to do the ordered pair for this point, starting from the origin on the x-axis, we're going in the negative direction 2 spaces, so -2, and then we're going in the positive direction 1 space. For this spot right here, starting from the origin, we're going on the x-axis, we're going in the negative direction 2 spaces, and then we're going on the y-axis in the negative direction 1 space. So notice those 2 points have the same x number. They both have -2. So the fact that that vertical line is touching 2 dots tells you that those 2 x values are the same. You have repeated one of those x numbers, which is what we don't want. All right, a couple more here. Let's use vertical line test to decide if this is a function. Okay, so I'm going to move over to here, and I want to stress here that here's what we're looking for. You've got your red vertical line. This is your graph. So you want to know how many times the red vertical line is touching this shape. Well, that red vertical line touches that point on the yellow shape and that point only. So that's 1 point. That's good. All right, let's move it. Well, can't get it. All right, let's move it over a little bit. All right, now how many times is that red vertical line touching that yellow shape? Well, it's only touching it right there. So that's only 1 point. That's good. All right, let's move him again. Can't seem to get a hold of him. Nope, I don't want the graph, I want you. All right, so let's drag him over a little bit. I'm going to go a little further this time. All right, that red vertical line and that yellow shape on the graph intersect right there. That's the only place they touch, so that's only 1 point. That's good. Move it over one more time. Right there's where the red vertical line touches that shape, only 1 point. So I'm seeing my vertical lines only touch 1 point each. Touching 1 point is good. So this is yes. This is a function. All right, so let's recap what we've just talked about here, okay? Let's make sure we've got it. A function's job is to make connections. A function is supposed to take an x and connect it to a y. And that makes, remember, these ordered pairs. All right? X is the domain number. Y is the range number. X is the input. Y is the output. Okay. In a function, you want no repeating x values. So in a function, you want no repeating x values. So that means all x's must be different. So if you have your numbers, and you want to know if it's a function, look at those x's. Make sure they are all different. If they're all different, it is a function. If some of them are the same, then it's not. And then on a graph, you're going to use your vertical line test. So if you've got a graph that has this shape, notice if I draw a vertical line through that graph, it touches that curvy shape at one spot and one spot only. So this would be a function. But if I had a graph that looked like this, if I drew a vertical line, it would touch that circle at 2 different places. Whoops, that was the wrong dot to draw. Sorry about that. Let me erase him. Let me fix what I just did. All right, so my vertical line touches the circle here, and then again here. So I have one vertical line touching 2 points on that circle. So this is not a function. Now, on today's assignment, you are going to be just simply looking at some things and saying, yes, it's a function, or no, it's not. And the way that I did this is I've given you on each question a green smiley face or a red X. So if you think the thing you're looking at is a function, drag the green smiley face over and place it on top of the problem. If you think it is not a function, then grab the red X and drag it over and place it on the problem. So you'll drag and drop one of the two symbols over and put it on top of the problem to say yes, it is a function, or no, it's not. Now, it's really important that you understand what makes something a function. So if anything that I've said today doesn't make sense, if anything is not clear to you, then please email me and let me know, and we'll get you some help on it. All right, do your assignment, work hard these next 2 weeks before Christmas break, and you know, stay in contact with Mr. Mossholder and I, and let us know if there's anything we can do to help.